Hi everyone, welcome to this YouTube channel at Best Science Brain YouTube tutorial. Today we're trying to look at displacement reaction, a topic meant for students in secondary school, those in SS2, senior secondary 2 and senior secondary 3, and also for those that want to learn chemistry more. So today we are going, if you are not subscribed to the YouTube channel or this is the first time you're seeing this video, please do well and subscribe to the channel. Go to the YouTube name. If you look at the YouTube name, you see Best Science Brain. Under it, you're going to see a small bell. Tap on the bell only once. Tap on it only once and get subscribed so that you can be seeing our videos from time to time. So today we're looking at displacement reaction. We define the term displacement reaction. We say displacement reaction is a reaction in which an atom displaces another atom or group of atoms from its compound. So look at the illustration. An atom S coming into a compound SY. S is in solid state, SY is in solution or aqueous state. Let's say A is in solid state, then SY is in aqueous state. A goes to replace S, giving us AY, and then S coming out to be in solid state. You notice something important here. A was formerly solid. Here A had joined Y to be in solution in aqueous state. While S that was dissolved before now takes the state of S to become solid. So for A to displace S or to replace S, A must be more electropositive or more electronegative than S. A will be more electropositive than S if A is a metal. While A will be more electronegative than S if A is a non-metal and also S is a non-metal. So what I'm trying to say is that we need a stronger element to displace a weaker element. A weaker element cannot displace a stronger one. Rather, a stronger element will displace a weaker element. So for A to displace S, that means A is stronger or more reactive than S. Let's look at this example. Zinc plus copper sulfate. Zinc goes to displace copper because zinc is more electropositive than copper, giving us zinc sulfate and then copper coming out to take the place of zinc, that is state, solid state. So why is it possible for zinc to displace copper? It is possible because zinc is more reactive than copper, or zinc is more electropositive than copper. Can copper do the same for zinc? Can copper displace zinc from its solution? Can copper displace zinc? The answer is no. Copper cannot displace zinc because copper is less reactive than zinc. So these are some instances of displacement reaction. Look at the first equation. In this reaction, zinc had displaced copper to give you zinc sulfate and copper because zinc is more electropositive or more reactive than copper. Look at the second equation. Iron will able to displace copper because iron is more reactive than copper. Then magnesium, the third equation, we will displace zinc because magnesium is more reactive than zinc. So we observe that these reactions are possible because, or are feasible because, the metals coming in are more reactive than the ones they are substituting. So displacement reaction sometimes can be called replacement reaction, or is a kind of substitution reaction whereby an active element comes in to replace a less active element. Now, how do we know whether element? How do we know the reactivity of element? To know whether element is reactive to than more than other, we have to visit the electrochemical series. Okay, so we are looking at, I say that for you to know the strength of elements, you have to visit the activity series. So here we have the activity series for cations. Cations are positive ions, which include mainly the metallic ions. So we have a mnemonis for knowing it, potassium, sodium. So please stop calling me. So that you look at the first letter there, P for please, P stands for potassium, stop, S for sodium, calling, C for calcium, me, M for magnesium, A for aluminium, zebra, Z for zinc, instead, this is iron, ferrous, I for iron, tel, T for tin, this is tin, Laura, L for lead, how, H for hydrogen, copper, C, then helps for mercury, strengthening, that is silver, Ag, gold, Au. So please stop calling me a zebra, instead, please stop calling me a zebra, instead tell Laura how copper helps strengthening gold. So these are the series for the cations, and then the reactivity of this element decrease as you go down the series. That means potassium is the most reactive, followed by sodium, followed by calcium. That means potassium can displace any of the cations under it from its salt. Sodium can displace any of the cations under it. Calcium can displace any of the cations under it. Now let's look at the example over there. So zinc is able to displace copper. Why? Let's look at position of zinc. Look at position of copper. So zinc could displace copper because zinc is more reactive than copper. Now look at equation number 2. Magnesium displaces iron to give all this product. Why? Look at magnesium. Look at iron. So magnesium is higher than iron or more reactive than iron. Then look at equation number 3. Calcium displaces silver to give all the products. Why? Look at calcium position. Look at silver. So what I'm saying is that an element can displace another if it is higher than the one it displaces in the series. If you have this, as I said before, this reaction cannot take place. Why? Because copper, look at copper position, copper is lower than zinc. So copper cannot displace an element that is stronger than itself. So that is it. The basis of displacement reaction is the activity series. Now, metals will displace only metals, or cations will displace only cations. While anions, which is negative ion, will displace only negative ion. The example we are taking so far is on cations, whether it's positive ion displacing other positive ions. We're now going to look at displacement reaction involving anions or involving negative ions. So we are looking at the anion, the activity series for the anions. We have this chloride ion, sulfate ion, nitrate, chloride, bromide, iodide, and hydroxide ion. We have anemones for knowing it, flying stop, no. To make it a little bit understandable, we'll move from down. We say O's in Britain can never stop flying. O's in Britain can never stop flying. So the reactivity decreases as you go down, with fluoride ion being the most reactive and hydroxide being the least reactive. Let's go to the examples over there. In the example, we see that chlorine was able to displace its fellow anion. anion will displace anion, while cation will displace cation, as I said before. So chlorine will displace bromine. Why? To give you sodium chloride and bromine molecule. Why is it possible? Look at fluorine position. Chlorine position, look at bromine. Chlorine is more reactive than bromine. That's why chlorine is able to displace bromine to take its position. Now let's go down. We have fluorine displacing iodine from its position. Why is it possible? Because fluorine is more reactive than iodine. Look at fluorine and look at iodine. So fluorine is more reactive than iodine. So fluorine was able to displace. Okay, look at this reaction. Fluorine was able to displace iodine because fluorine is more reactive than iodine or more electrolytic than iodine. So you're able to displace iodine to take its position. So what if you look at this reaction, bromine plus sodium chloride? Can this reaction take place? Is it feasible or is it spontaneous in chemistry? In chemistry, when the reaction is spontaneous or feasible, means that reaction can take place. This reaction can't take place. Why? Bromine cannot displace chlorine. Look at bromine position here, down there. Look at chlorine. So bromine is lower than bromine. Bromine is lower than chlorine, or bromine is less electrolytic than bromine. So this kind of product is not possible because bromine cannot, this is the wrong reaction, cannot displace chlorine. In other words, what we're saying is that in displacement reaction, you need a more active element to displace a less active element. If it's a metal, a more electrophilic metal to displace a less electrophilic metal. If it's an anion, you need a more reactive non-anion to displace a less reactive anion. For instance, the anion series, only the one higher in the series can displace the ones lower from their solutions or from their source. Then is for cations, only the ones higher can display the ones that are lower from their solutions, as we explained before. Now we're going to take a little practicals on this topic. Yes. So on the practical aspect, we're going to add iron filings or iron dust to copper sulfate. Iron filings to copper sulfate. Copper sulfate has a pale blue color. On addition of iron sulfate, of iron dust to copper sulfate, what do you expect? Can copper displace, iron displace copper? Yes, because iron is more reactive than copper. Iron will displace copper, we now have iron 2 sulfate, which is going to have a green color. And then we're going to have reddish brown copper deposit. So in this reaction, we're going to demonstrate now, we're going to add iron dust to copper sulfate. And what we're going to observe, what do we expect to observe? We expect to observe a green solution and a reddish brown deposit, which is copper. Okay, now we have the practical aspect. We have this is copper sulfate solution, pale blue in color. This is iron dust on a spatula. So we're going to empty the iron dust into the copper sulfate and allow them for a few minutes to react together and see whether actually we're going to observe what we have on the whiteboard. So as you can see, the blue color of the copper sulfate is gradually changing. Color is changing to pale green. So we have this. You can see that we have a liquid on top, turning to almost is all like bluish green in color. And then we have reddish brown deposit under. which represents the rigid brown deposit formed under is the copper produced, and then the bridge drain solution, which is actually turning to pale green, is the iron 2 sulfate solution, showing that iron was able to displace copper because iron is more electropositive than copper. So always stay connected to the channel, and if you are not subscribed, subscribe by hitting the bell on the channel page, the small bell, and get subscribed. Tap on it once and get subscribed. Thank you for listening.